There are millions of components on the surface of a chip. Every component has a number of points, called pins, by means of which it is connected with other components. Here, for example, is a circuit which performs the logic function AND, which has 2 inputs and 1 output pin, that is, 3 pins in all. The result produced by this circuit is either stored in memory or processed further somewhere else, in this case at 3 different places on the chip. So the output pin of this AND circuit must be connected to an input pin of each of these 3 components. These 4 pins form a so-called net. The purpose of the routing step is to determine a way of connecting the pins of each net. In reality, the connections are not actual wires, but very thin metal vapor depositions. Such a connection of pins is called a Steiner tree for the net. The Steiner tree for a net should, of course, be designed in such a way that a signal reaches the input pins as quickly as possible. Longer connections also use more power. So it is usually important to determine a shortest Steiner tree for each net. Unnecessary detours must be avoided. But it is not easy to find optimal Steiner trees, especially when there are many pins involved. You can attempt this yourself by trying our interactive game. It is not, however, sufficient to find an optimal Steiner tree for each net separately in order to obtain a routing. The different Steiner trees must not touch, for example, as this would result in a short circuit. So one uses different planes, and sometimes also allows detours. On a chip, there are usually several million nets and up to 20 routing planes. So-called vias provide connections between the different routing planes. A single chip can have a total routing length of over 1 kilometer and many millions of vias, all on the surface of just a few square centimeters. There are many criteria to fulfill in order to obtain a functioning chip. Such routings can only be achieved by means of algorithms of discrete mathematics, about which more will be said in the next film.